This is the linear programming handout example on Blackboard. I'm going to do it by hand and graphically. So this is the graphical method. For linear programming, it is much easier to do it in Excel and much faster if you understand how to do it using the add-in solver. But I will go ahead and show you graphically how it's done. The company makes pottery bowls and mugs, and we're given the information on the profits and how much clay and labor it uses. So if we wanted to summarize the information, we would write here on the side, we're making bowls. We'll use B for that, and M mugs. We're using both labor and clay, and we're using 1 hour of labor for every bowl, 2 hours of labor for every mug, and we have available 40 hours of labor. I recommend that you summarize the information to make it clearer for you to solve the problem. To start with, clay 4 pounds per bowl, 3 pounds for mugs, and we have 120 pounds available. And the profit we make for bowls, it is $40 per bowl and $50 per mug, and profit being revenue minus cost. So when you're solving an LP problem and you want to formulate the problem, we first have to decide what are the decision variables. What are we trying to decide here? So we're trying to decide how many bowls and how many mugs to make. So instead of using X and Y or X1 and X2, I prefer that you use variables that you are very familiar with. So B would be much better than using X. So B would be the number of bowls to make. Similarly, M would be number of mugs to make. This is what you're trying to decide, how many of each to make to maximize your profit. So why not use variables that make sense rather than X and Y? So then after you decide what the decision variables should be, you're going to decide what your objective function is. And so your objective function is going to be maximize profit. So you're maximizing profit, but you don't know how many of B's and how many of M's you're making. But for every B you make $40 profit. For every M you make $50. So your total profit equation is going to be 40B and 50M. But that is subject to constraints. So your constraints, and constraints are things that holds you back from making infinite amount of profit. So subject to. And that would be your constraints. Constraints can be equal to, less than, or greater than or equal to. So what are our constraints here? Usually the constraints are the resources. So we have labor, constraint and clay constraint. We only have so much of these constraints. We have 40 hours of labor and 120 pounds of clay. So we'll start with the labor. We use 1 hour per bowl, 2 hours per mug, and we have 40 hours of labor. So that would be 1 times B, so that's a B, plus 2 times M less than or equal to 40. That would be the labor constraint. Similarly, the clay constraint would be 4B plus 3M less than or equal to 120. That would be the clay constraint. These are the only 2 constraints we have. We always have non-negativity constraints. Bm is greater than 0 because we want to make sure that we don't make anything negative. It doesn't make sense. So we're always in the first quadrant. Okay, so the way to solve this problem graphically is we always draw the graph, and we can only solve LP problems graphically for 2 decision variables. It can be any number of constraints, but only 2 decision variables. Why 2 decision variables? Because we only have a plane, x and y axis. We cannot draw in 3 dimensions or 4 dimensions or 5 dimensions. So we come here and draw an x and a y, and we decide what do we want to be our x-axis for B, y-axis for M, and then we try to be very consistent in how we plot B and M. So then we draw the constraints basically. So we take the first constraint, and that's B plus 2M equal 40. The easiest points to draw are the intercepts, the x and the y intercepts. You only need 2 points to draw a straight line. And this is a straight line because b to the power 1, m to the power 1. So the x-intercept and the y-intercept, you plug 0 for b, 2m is 40, so m is 20. And the other intercept is you plug 0 for m. If m is 0, b is 40. So that's 0, 20, and 40, 0, 10, 20, 30, 40, 0. So that's your first line. But that's only the point on the line. The constraint tells me b plus 2m is less than 40, so we have to test a point to see is it below the line or above the line. So let's test the origin, 0, 0. Is 0 plus 2 times 0 less than or equal to 40? Yes, 0 is less than 40, so we're really looking at the region below the line and on the line to represent the first constraint, the labor constraint. So this is labor. This is labor. Now let's look at the second constraint. 4b plus 3m is equal to 120. So if b is 0, m is 40. If m is 0, b is 30. So 0, 40 is here, and 30, 0 is here. So we draw a straight line.